Hi guys, welcome to your 9-3 notes. Today we will be solving quadratic equations. Over the next few lessons, we're going to look at a bunch of different ways of solving quadratic equations. The first way today is going to be by graphing, and then we're going to solve it with square roots. So by the end of the day, you will be able to solve quadratic equations by graphing them and by using square roots. So you'll recall from previous lessons that a quadratic equation, quadratic means squared, is an equation that can be written in the form of ax squared plus bx plus c equals 0. When we have it in this order, with our quadratic first, and then our plane x, our linear term, and then our c, our constant term, we call that the standard form of the equation. This is standard form because our exponents on our x's are in decreasing order. They get smaller. Are 2, 1, and then 0. It's not even there. So solutions of a quadratic equation are going to be where the graph intersects the x-axis. We also like to call these guys the roots of the equation. We also call them the zeros of the function. We'll go back and look at this definition again, and it will make some sense. Well, hopefully make more sense after looking at the pictures. So we're going to start out by solving each of these guys by graphing. So let's graph x squared minus 16. This minus 16 means we're going to move our graph down 16, and we've got a standard x squared, so it doesn't need to squeeze or get fatter. So we go down here, and this is what our graph looks like. As you can see, we've got our nice parabola. It's facing up, but instead of starting with its vertex at the origin, it has moved down to have its vertex at negative 16. Now, like we said, we want to find solutions of this equation, of this graph, of this equation, of this graph. And that's going to be where the graph intersects the x-axis. Our x-axis is this guy right here. So our roots are going to be right here at x equals 4 and right here at x equals negative 4. So we can say x equals negative 4 and x equals 4. You can write your solution like that. You can write your solution also as x equals plus or minus 4. That works. Or if you want to say x equals 4 and x equals negative 4. Each of these works. You can write your answer like this, or like this. And those are all totally fine. My personal favorite is this one because it takes the least amount of time. So there you go. Now we call these roots because if this were a plant, that's like where it's rooted in the ground, kind of. So there you go. They're also called zeros because that's where y is 0. It doesn't go up or down at all. It hits right there at the x-axis. So that was one. Now we're going to go ahead and graph equation B and equation C. To find its solution, remember you want to find where it crosses the x-axis. So go ahead and graph each one and find where it crosses the x-axis. Starting here, we've got a graph that intersects at y equals 6 when x is 0, y equals 6, and then we're going to squeeze it to be 3 times as skinny. So this gives us a parabola that looks like this. Now you'll notice, if we want to find the zeros where they intersect the x-axis, it's not there. This graph has no x-intercept. Oh no! That means because it has no intercept, it has no solution. That's it. That's the answer to that one. Because this graph does not intercept the x-axis, it has no solution. Now finally, here we've got x squared minus 25 equals negative 25. Ooh, that's gross. That's not in standard form. It's not equal to 0. So we need to get a 0 on this side. To get a 0 on that side, let's quick add 25 to both sides. And that leaves us with x squared equals 0. This is our parent function. Just a plain old x squared is super easy to graph. We've got a vertex at 0, 0, and then a standard parabola. Awesome. Now again, we want to find the zeros, we want to find the solutions, we want to find the roots at the x-intercept. So we're going to go ahead and find where our graph intercepts the x-axis. There is one point. It is this point right here. That's when x equals 0. Awesome. So our one solution is x equals 0. Now you'll also notice that each of these graphs has a different number of solutions. This one had 2 solutions. This one had 0 solutions. And this one had 1 solution. So sometimes you'll have a graph that intercepts twice. Once here, once here. That graph will have 2 solutions. You can have a graph like this one that intercepts the x-axis once, like here. That has 1 solution. And this one intercepts the x-axis 0 times. So it has 0 solutions. Again, the solutions of our quadratic equation is where the graph intercepts the x-axis. You can have 2 solutions, 1, or no solutions at all. So that was solving by graphing. We're also going to solve by finding square roots. Before we do, let's quick review how to simplify quadratic expressions. Here we've got the square root of 36. You'll remember that the square root of 36 is 6, but it's also negative 6. So we say it's plus or minus 6. This is because 6 squared is 36. Also, negative 6 squared, that's negative 6 times negative 6. That's equal to a positive 36. So we say that quadratics, that radicals, that square roots have a positive value. They also have a negative value. So it's very important to keep in mind that when we're solving radicals like this, that we have a plus or minus answer. Similarly over here, the square root of 81 is 9, but it's also negative 9. So we get plus or minus 9. What about here on C? The square root of 0 is plus or minus 0, but negative 0 is 0, so it's just 0. Yay. And then finally, the square root of negative 9 has no solution. You cannot have a square root of a negative number. We just say there's no solution. Cool. If you're like, wait, Miss Van Dyke, why isn't it negative 3? Because the square root of 9 is 3. So why isn't the square root of negative 9 equal to negative 3? Well, let's find out. What is negative 3 times negative 3? Because that's negative 3 squared is when you take it and you multiply it by itself twice. Well, that's a negative 9. Oh, positive 9. So that's why negative numbers do not have square roots for now. So let's go ahead and solve each equation. Now the fun part about solving equations with square roots is they behave exactly how, hopefully, you would expect them to behave. When we're solving any equation, our goal is always to get our variable all by itself. So we're going to undo all this stuff that's happening to our variable and see what we get. So the first thing we want to undo is this minus 16. We're going to add 16 to both sides. This will give us that x squared plus 16 minus 16 cancels out. 0 plus 16 is 16. Sweet. To undo this x squared, we want to take a square root of both sides. Now the square and the square root, those are going to cancel out. So we just get x equals, what is the square root of 16? Yay, but remember, plus or minus 4. Very fun, right? Of course. Now next, yeah, that's our solution. X is plus or minus 4. Or if you want to say x equals 4 and x equals negative 4, that's fine as well. They mean the same thing. Let's solve this guy. First, we want to minus 6 from both sides, and that gives us 3x squared equals negative 6. Cool, so far so good. Now we've got this 3 here, so to undo 3 times, we're going to divide by 3. And that gives us that x squared equals negative 2. And in one last step, we want to undo this x squared. So we're going to take the square root of both sides. The square root and the squared will cancel out. That's the whole reason we did it. And now the square root of negative 2. We can't have a square root of a negative number. So instead, no solution. Guys, we forgot to check our work. Let's go back to A and check our work real quick. We claim that x equals 4. So let's plug it back in. Is it true that 4 squared minus 16 equals 0? Again, we take our x equals 4. We plug it in right here. 4 squared minus 16 equals 0. Well, 4 squared is 16. 16 minus 16 equals 0. Awesome. Let's check our other one. If x equals negative 4, we plug that back in, giving us negative 4 squared minus 16 equals 0, maybe? I don't know. Let's find out. Well, negative 4 times negative 4 is positive 16, and 16 minus 16. Oh, yep, that's 0 again. We did it right. Yay. Now, we can't check our work here because we don't have a solution. There is no number out there that will make this true. No matter what we plug in for x, we'll never get something equal to 0. Let's try our last one. Let's solve this guy. Remember, we're trying to get x all by itself. So, to undo this, we'll add 25 to each side. These will cancel out. Awesome, leaving us with just x squared equals negative 25 plus 25. Well, that's 0. That's fun. I like when that happens. To undo the square, we're going to take a square root, giving us that x equals 0. That's our solution. Now let's check and see if it worked. Is it true that 0 squared minus 25 equals negative 25? Well, 0 times 0 is 0. 0 minus 25 is in fact negative 25. So yay, we did it right. Now that's great, Miss Van Dyke. I'm so glad that we can solve equations by taking square roots like we did here, here, and here. I'm also glad that we can solve quadratic equations by graphing them. This is cool because it allows me to see what the solutions are. That's awesome. But when are we going to use this in real life? Well, I'm so glad you asked. Maybe you would just get so bored at home that you decide you're going to go make a garden and you need to have a you're going to plant a circle garden in your yard. So it's going to be this beautiful circle right here, and you know that the area of your garden can be 200 feet squared because that's how many shrubs they gave you. Awesome. Now you need to figure out how big is this circle gonna be. I'm gonna find out what is the radius. What's the radius of this circle right there? Now just to keep in mind, to find the area of a circle, this area is pi times the radius squared. Okay, now let's use that to find out how big our circle is going to be. Alrighty, so we know our area is 200 feet squared, so say 200 equals pi times whatever our radius is, and then square it, and then let's just simplify it. So we're trying to get this r all by itself, find out what that radius is. So first we're going to divide by pi. Now you remember that pi is the ratio of a circle's circumference, that's the distance around the circle, divided by its diameter, that's the distance all the way across the circle. And this is approximately equal to 3.14 for every circle. It's just approximately equal to that. All right, so pi is a number. That's what I meant to say. So pi is this number, so we have this expression 200 divided by pi is equal to r squared. Now 200 divided by pi is some number. I didn't even write it down, but I can approximate it for you real quick. 200 divided by, this is fun fact, approximately equal to 200 divided by 3.14, which comes out to about 64-ish. But that's not important right now, just in case you're curious. This expression is about 64. But I like to be super precise. So instead, I want to solve this guy by taking the square root of both sides. I'm going to take the square root because here the square root and the square, those will cancel out. And that will give me just a plain old r. And I'm going to take the square root of this whole expression, and that comes out to 8.0 feet. Isn't that great? 8 feet. So I need to measure my circle 8 feet long. Now, to actually do this, what I would do is I would get a rope and I would measure out the rope that's 8 feet. And then I would have one person stand in the middle of my circle right here. And then I would stand on the outside of the circle right here, and we'd hold the rope. And then I would walk all the way around, and that would give us our circle. So there you go. That's how we would use this in real life. Isn't that great fun? Of course it's great fun. So this is how we use quadratic equations in real life. We started out with our area of the circle. We plugged in the information that we knew, and then we solved using square roots to find the dimensions of our circle. So yeah, quadratic equations can be solved by taking square roots. They can also be solved by graphing and looking at where the zeros of the function are. If you have any questions, please reach out, and I hope you have a wonderful day.